So this video is looking at compound interest. We have previously been looking at simple interest, which was just a flat rate, and it was the same amount of interest every period, time after time after time. Whereas compound interest, the amount of interest keeps growing. So we have a term deposit, which is a lump sum, and you end up earning interest on top of interest. So that amount of interest keeps growing and growing. And this is our formula here. The FV stands for future value, the amount that you will have in the future. PV is the present value, the amount that you have now. That's a 1 plus I. Now I is your interest rate, and you need to make sure that you have to remember to divide that by 100 and divide by the amount of times it's compounding. And we'll do a couple of questions down here in a minute to show you what that means. And N is the number of interest payments that you will receive over the length of the loan. So we're going to put this into practice now. It's a lot easier to see how it works when we actually do it. So we're going to do the first one here, the annually. Now, a couple of these terms, let's see what they mean. So annually, that means once a year. Quarterly, that's 4 times a year. Monthly, we know, is 12. And daily, assuming no leap years, that's 365. So we're going to do each one of these and just see how they differ depending on how the interest is compounded, all right, whether it be annually, quarterly, monthly, and so on. So let's start with the first one, where it's annually. So as soon as we read the question, because remember, you're going to be mixing these questions up, and sometimes it might be simple interest. So if you see simple or flat rate, you're talking simple interest, and as soon as we see compound here, we need to write our formula down. So it helps if you write it down, and that will help you remember it. So future value equals present value 1 plus I to the N. And what I recommend, and this is, we're doing A here, what I recommend is that you then write down the information that you have. So do we know the future value in this case? No, we're trying to find that. The present value is the amount that we have originally. So interest earned over 2 years, sum of 18,000. So 18,000 is our present value. We read on, the I we should be able to see. Now it's 4 3/4. Now 3/4 is a decimal, is 0.75. So to write that as a decimal, you can pop in your calculator, you can say 4.75 divided by 100. We jump the decimals there, so that's going to be 0.0475. And we've divided that by 100. We then have to check how many times is it compounding. And it's just once, so I don't have to write divide by 1. That would be a bit silly. And then N is the number of times it's compounding. So it's compounding once a year for, here we go, 2 years. So therefore N is 2. Okay, and all we have to do now is pop that into our formula. So the present value we've got there, it's 18,000. Oops, better put one more 0 there. And we know there's a times there in between. 1 plus, we pop that 0.0475, and it's going to be to the power of 2. And we just plug that straight into our calculator over here. Okay, so into normal run mode, and we're going to have 18,000 times 1 plus 0.0475, close bracket, to the 2. Okay, and equals, so 19,750. 19,750, and let's just check how many cents that was, and 61 cents. Okay, done and dusted. While we're here, might as well just show you that you can check this on the financial part of your graphics calculator. So if we go menu, see here, financial. Now if you've got a slightly older calculator, that will be called TVM. You'll see a little $sign there. So just, use that one. You can see here we've got compound, so we go F2. N, it was for 2 years. Our interest was 4.75. Our present value is 18,000. So you notice that we've got the same sort of terminology that we have in our formula. Okay, payment, PMT is for payment. Now we don't have regular repayments. This is a lump sum, so we're going to set that to 0. And the payments per year, or the amount of times that it's compounding per year, because it's annually, we're going to put the 1 there. Okay, and then actually if you come back up here, sorry, it's just how the formula works. If you could just pop a negative in front of that, negative. And we want to solve now for future value, so we press FV. You can see we get exactly the same answer. Okay, so let's go back and see how it changes when we do the next one, when it compounds quarterly. Okay, so let's see how things change when it's now quarterly. So our future value, we're still trying to find that, so I'm just going to put it to the side a little bit here now. So the future value, we're still wanting that. The present value has not changed, that is still 18,000. But this is where it changes. So your interest now, instead of just being 0.0475, remember that has come from 4 3/4, because it's being compounded quarterly, I have to divide that by 4. And I'm just going to leave it like that. I'm not going to go to the calculator just yet and round it off to a decimal. I'm going to do it all at once at the end. And our N, again, it's 2 years, but you're getting interest 4 times a year. So N will be 2 times 4, so 8. And this is what we pop into our formula now. So we say, write it again, future value equals present value, 1 plus I to the n. You keep writing that, you'll just remember it. We get 18,000 times 1 plus, and now I write my interest here, so 0.0475 all over 4, and that is to the power of 8. Okay, and off we go to our calculator here. We go back to normal run mode. Oops. And we go 18,000 times 1 plus fraction button 4, oops, 0.0475 all over 4. Close your bracket to the power of 8. And let's see what happens now. So we've got 19,782. $19,782, and how many cents do we get? So 78.5, so that's going to round up, so 0.79. Okay, how does that change on our graphics calculator if we go into using the financial function? So once again we go back over here, press enter. So now what changes? The interest is still the same. By the way, I forgot to show you, we didn't have to divide that by 100 because the calculator already did that for us. So that stays the same with quarterly, but our N is different. So that becomes 2 times 4. So I can just pop that in. This will divide your interest by the number of times it compounds already. So you just leave the interest as is. But down here, you have to pop in how many times it's compounding, and so because it's quarterly, we pop 4 there. If it was monthly, the thing that changes, that would now be 12, and of course our N would be 2 times 12. Anyway, we pop that in, we go future value, and you can see we get the same answer that we got using the formula. Okay, so back over here, how will things change if it's now monthly? So I'm going to cheat a little bit here and just erase the bits and pieces. And we'll see how do things change when we're doing C now. So with C, the thing that changes, future value we're still finding, present value is still the same. But now, because it's monthly, we have to divide the interest by 12, and we have to times the period by 12, so that now becomes 24. So in our calculators, that goes to 12. The N now becomes 24, and you can type this in to your calculator, or in the financial mode, you can check. Oops, so we're in there. You just now press exit. So we go back up to the n, so that's now 2 times 12. Interest is still that, present value is still that. We scoot down here to the compounding and we say that that is 12. And now when we press enter, we press FV, we get 19,790. So we've now got $19,790, and what was it? So 15 cents. We'll check that in the normal calculator in a minute. Now you can see it's getting bigger and bigger each time. Okay, when it was compounded quarterly, it should still be in my calculator here. What was it? It was 19,782. So 782 from 750 it went to 82. Now it's gone up to 90. So the more times that you compound, the more interest on interest you earn, and it will get a bigger sum. You can imagine if this was a larger value, you'd get a larger amount of interest. If you kept it in the bank for longer, so instead of just 2 years, if you went for 3 or 4 years, you'll find this difference would start to get bigger and bigger and bigger. Okay, so I won't bother now with the daily, because everywhere here that we've put the 12 that would now be 365, and you'd say 2 times 365. So it becomes a little bit repetitive once you have done one of these. Okay, so how can things change? All I can do is change the amount that you borrow. I can change the interest rate, and I can change it for how long, and of course how often it's compounded. But if you follow these simple steps, you won't get it wrong, and you can check on your calculator the graphics and in your normal run mode. Let's look at just one slightly different problem. Okay, so a slightly different problem. And once again, we read, calculate the amount you would need, blah, blah. I'm skimming, and as soon as I see, again, compound interest, compound monthly, I go, ah, ha, ha, it's compound. So again, I'm looking at this formula here. So calculate the amount you would need to invest now. So that's, in this case, we're actually trying to find our present value. So if we list down what do we have, future value, present value, I, and N. Okay, so we don't know that. In order to accumulate, so you want to get, all right, 25,000, you want that in the future. So that means our future value is 25,000. In 5 years' time, so we know that N is 5, but we have to check how many times is it compounding. Monthly. So that becomes N is 5 times 12, 60. If it was compounding quarterly, I'd times by 4. Okay, but it's 12, so we put 60. And then last but not least, the interest rate. Remember, let's divide that by 100. We're in the groove now, that's 0.045. So you just move the decimal 2 spots over, 1, 2, fill it with a 0, so 0.045. And again, because it's compounded monthly, we have to divide it by 12. Now I could write this formula down and substitute it in, or before I substitute, I can look at this and go, I don't want FV, I want PV, so I want to get this by itself. So how do I get rid of this whole times? The opposite of timesing, everybody, is, right, dividing. So that means I can rearrange this equation, and I can say this is the future value divided by 1 plus I to the n. So that's what I will write down here. Present value equals future value over 1 plus I to the n. And I suggest that you add this to your formulas, okay? And now we just substitute our information in. So we've got 25,000 all over 1 plus, now our I is 0.045 all over 12 to the 60. And off we go to our calculator. So use our fraction button. I've forgotten what it was. There's the memory gone. So 25,000 and downstairs bracket 1 plus, and we want to divide 0.045. It was monthly. Okay, and was it to the 60? Yes, it was. Okay, so to the 60 equals, so 19,971. $19,971.30. Okay, so I'd like you to write this down. I would also like you now, as you're doing some of these questions, I want you to then go and check on here. So how does this work if we use the financial function in our graphics calculator? We come back once again, we're going to go to compound interest, so we press F2 and we type in, that was, go back over here, what was our N? 5 times 12. So we pop that in there, 5 times 12. The interest was 4.5. So remember, when you pop that in here in the calculator, you don't have to divide it by 100. Our present value, we didn't know what that was, so we're going to put that as 0. Our future value, we wanted 25,000. You didn't have to make that 0. Oops, I popped that as PMT. That's not right. So just change that back to 0. So we put our 25, 1, 2, 3. And are we happy that our PY is 12? Is it compounding 12 times a year? Let's read that again. Yes, it is. So we go back, and this time, instead of pressing FV, we're solving for PV. So 19,971, and that's the same answer that we got here. So I hope you can now check that if we wanted to find, if we had other information, so if I had N, if I had the future value, and I knew, let's go, okay, I started with, instead of I started with 19,971, what if I started with 18,000? This now becomes a question where I say, well, how long will it take for me, if I started with 18,000, I wanted to get 25,000, and this was the bank I had that offered 4.5%. So what I can do now is say, I'm now solving for N. So I can press N, and that's going to say it will have to be invested for 88 months. 87.7, so 88 months. How many years is that, just so we get an idea? I can just say that's 88 divided by 12. So 7 years and 3 months and a third, 7 1/3, so 7 years and 4 months. So you can see that part of the calculator is really good, the financial part, right, to fiddle around and manipulate things. What if I said, well, I know that I've got 18,000, I want 25, but I want to keep it away for 4 years. So 4 times 12. What bank or which bank would I have to find that would offer me a specific interest rate? So if I now press interest rate, it means I have to find a bank that offers an interest rate of 8.24%. And that might be just a little bit too unrealistic. Okay, so we can find the future value and the present value using our algebra skills, right? That's this stuff here that you were doing, fantastic. But when we have to find the actual interest rate or the N, that's a little bit harder for us, and we don't need to do that, okay? So hopefully that gives you a good understanding and how to use your calculator with compound interest, and good luck. Hopefully that helps with parts of the assignment.